Hi everyone, so today I'm going to be doing the plane waves problem number 1, and it is as followed. Given that the E field is y hat 0.1 sine 10 pi x cosine 6 pi times 10 to the 19 minus beta z, in air, find the H field and beta using the Phasor equations. So this one is about a relatively simple problem. If you were to do the other methods, but this problem is explicitly asking for you to do it in the Phasor equations. That means the first thing you have to do is convert this E field into Phasor. So if you don't remember how to convert stuff to Phasor, you just remember the a cosine omega t plus theta just equal to the real part times a e j omega t plus theta, or this is also just equal to the real part e j theta times e j omega t. So to convert this, we just have to follow this equation. But a simple trick that you can do is you actually don't really have to write the t term. Oops, this t term right here. You don't have to write this term explicitly because this term is always going to be here. We're able to just write this as E is just equal to the y hat 0.1 sine 10 pi x e to negative j beta z. So we essentially just ignored this t term, but it is here, but we do not have to write this term because this t term will always show up in every E field or in every single equation. So you can think of this as writing it in a shorter way. So after this, we have two important equations that we can use, and the first equation that you can use is the curl of E is equal to negative j omega h. So this is the first equation that we can use, and the second equation that we can use is the curl of h is equal to j omega epsilon times the E field. So because we need these two equations, because it's asking us to find two unknowns while we only have one equation, that means we need to use these two equations to find these two unknowns. So what this equation essentially says is that it's basically saying that a curl of E is equal to the negative j omega mu times the H field. And this is just a gradient vector, and this is just the E field. And we know what the E field is, and we know what a gradient is. So the gradient crossed with E field is just this. You have an x component, y component, a z component. It will be the partial derivative of x, partial derivative of y, and a partial derivative of z times each component of the E field, which we're going to find right here. You just have to understand that you have to use the Phasor notation for this because this equation only works for a Phasor. And according to this, we only have the E field in the y hat component. That means we're able to just write it, right? 0.1 sine 10 pi x times e to negative j beta z, which is just the same as this, written right here. while the other components are going to be 0 and 0. This equation can just be found on page 18 of the Maxwell Equation PowerPoint that's posted on Canvas. So we just simply find the discriminant of this, and just to make things simpler, make sure to write that we know that's a plus, minus, plus. So we know that this, the gradient crossed with E field, is just equal to this. So negative j omega mu h is equal to this discriminant right here. So first we're going to start with h, so we first cover up this h term, and we're able to see it will just be 0, the partial derivative of y times 0 minus this whole thing times the partial derivative of z. So simply it's just 0 minus this. So in the x term, we will get 0 minus partial derivative of z times 0.1 sine of 10 pi x e to negative j beta z. Next, we can do the y term. So if we cover up this y term, we have these four terms right here. So the partial derivative of x times 0 will just be 0, and then minus 0 times the partial derivative of z. So this is just 0 minus y hat, and then we know it's 0. So plus now in the z hat direction, it will just be the partial of x times this whole term minus 0 times the partial of y. So we're simply just going to have the partial of x times 0.1 sine 10 pi x e to negative j beta z. So now we just have to take the partial derivative of this and this. So now I'm just going to rewrite the equation real quick. H is equal to, so after taking the partial for this part of z, you should get something along these lines in the x hat. You will get a negative, this negative will be here, times negative j beta times 0.1 times sine of 10 pi x e to negative j beta z. So if you guys don't understand how I got this, this is just asking for you to take the partial derivative with respect to z. And the way I look at it is, where are the z terms in this part right here? We only have z right here. That means we just have to take the derivative of this part. And that means that the derivative of this is just going to be this times negative jb. And this is what we have. So now to take the derivative of the second part with respect to x. And like before, you find where the x term is, which is just right here. That means we need to do a chain rule because it's inside this, inside the sign. So then that will just be plus z hat times 0.1 times cosine of 10 pi x times 10 pi times e to negative j beta z. So what we did was, So what we essentially did was we found the derivative of sine, which is going to be cosine, and you leave the inside alone. So cosine 10 pi x Then you take the derivative of the inside, because this is just going to be chain rule. And the derivative of 10 pi x is just going to be 10 pi. So cosine 10 pi x times 10 pi. So now just to simplify this, we got negative, negative, and then we have a 0.1 times 10. So to simplify this, we get negative j omega mu h is just equal to x hat times positive, positive. So just 0.1 j b times sine of 10 pi x times e to negative j beta z plus z hat, and 10 times 0.1 is just going to be 1. So we can just write this as so 10 times 0.1 is just 1 pi. So pi times cosine of 10 pi x e to negative j beta z. Let me draw this line to make things clearer. Draw another line to make things more clear. So now we're able to just find what the h term is. Sorry, this is actually a vector. Don't forget that. It's a vector. So now we can just divide the negative j omega and mu over to the other side. And we get h hat is then equal to this whole thing. So x hat times 0.1. I'm sorry for constantly changing papers. Times sine of 10 pi x e to negative j beta z plus z hat of pi times cosine of 10 pi x e to negative j beta z. I just copied this, divided by negative j omega and mu. I just divided this term over to the other side. So now to simplify, we just divide this into each component. Sure, okay. I'll just leave this here so it's easier for everyone to see. So to divide this, the j's will cancel out on the x term. So we're going to be left with x is just equal to, since it's make sure to remember this, it's a negative, so negative x hat times 0.1 beta, since the j's will cancel out, divided by omega and mu times the whole thing again, sine of 10 pi x e to negative j beta z. And the same thing can be said for here, where we can just multiply. Well, nothing cancels out here, so we'll just divide. So we're just going to be left with plus in the z hat direction pi divided by negative j mu omega mu times cosine 10 pi x times e to negative j beta z. So now we have our H field equation. Actually, this can be simplified even more, right? We know that -1 over j is actually equal to j. So this term right here can actually just be written as e hat j pi over omega mu cosine of 10 pi x e to negative j beta z. So now that we know what the H field is, we can use our second equation, which I said before. It's just going to be the gradient or the curl of H just equal to j omega epsilon times E. So the same steps are done, but this time we're crossing it with H, and we have our H terms right here. So if we were to do it, E cross of H is going to be equal to x hat, which is going to, and the x component is just going to be this whole thing right here, but make sure to not forget the negative. So it's going to be negative 0.1 beta over omega mu sine of 10 pi x e to negative j beta z, and then the y component, partial y times our y component, which we don't have, and then the z component, which is just a partial z. And that's simply just going to be this term right here. So j pi over omega mu cosine times 10 pi x times e to negative j beta z. So now we're simply just going to take the gradient or the determinant of this. Okay, so we know that the curl of H is equal to this, so j omega epsilon times the E field is just equal. So when we're trying to do the determinant for H, cover up the H like before, and we multiply this term times this term minus this term times this term. So the partial y times this whole component times minus 0 times the partial z. So that just means that we're going to get the partial of y times this whole term, j pi over omega mu cosine 10 pi x times e to negative j beta z, minus the y term, which is going to be this times this minus this times this. So the partial of x times this whole term minus this times the partial of z. So if I was to write that, that's very long. So y times partial of x times this term right here times j pi over omega mu cosine 10 pi x e to negative j beta z minus this times this. So the partial of z times, times this. So it's going to be negative 0.1 beta over omega mu sine 10 pi x e to negative j beta z. Okay, so now to do the z term, same steps again. The partial of x times 0 minus this times the partial of y. So this times this will just be 0, so we're just going to minus. So there's going to be minus this times this. So plus z hat is 0 minus the partial of y. And it'll be negative out here because of this term. 0.1 beta over omega mu sine of 10 pi x e to negative j beta z. And as maybe some of you might have realized this by now, this x term will just be 0 because we're taking the partial of y, and if you look at this component right here, there are no y terms, meaning it will just be 0. So this whole thing would then just be 0. And the same can be said for the z component because we're taking the partial of y and there's no y terms. So this thing would also be 0 right here. So 0. So all we're left is with the y component. So if I was going to simplify the y component, which is just going to be this whole line right here, we first take the partial of x. So remember that we still have this negative sign here, so make sure to keep track of the negative signs when doing these type of problems. So let's first, I will first rewrite it so it's simpler to see. Well, let's take the partial of x times this whole term right here. So j omega epsilon e hat is then just equal to minus y hat, and this minus is always here because it was minus right here. You can't forget this minus sign, so I'll just spot it over right here. So minus y hat. So once we take the partial of x of this, which is still going to be chain rule because there's an x in here, so that means we have to do chain rule, you will get this. J pi over omega mu times negative sine of 10 pi x times whatever's inside, which will just be 10 pi times e to negative j beta z. So I did nothing special, I just took the partial of x of this term right here. Just remember that the derivative of cosine is negative sine. Then minus the partial of z of this term right here. And the partial of z we only have to care about is this e term right here, since the z is only right here. So that means it would just be this times the derivative of this. So minus minus 0.1 beta over omega mu sine 10 pi x e to negative j beta z times negative j b. So like I said, the derivative of this will just be this times whatever its power is, which is negative jb. So let's just move this negative j beta term over here just to make it look nicer. And then we're able to simplify, get rid of this minus sign because there's a minus sign here, so it turns positive. So y hat times j pi over omega mu sine all I did was just multiply this negative JB over, just moved it over here so that it turns into beta squared. And this negative term, negative, so it turns positive. So now we can just plug in E, which is what was given in the beginning of the problem. Let me find my preset here. And the E term that was given was just this. So we can just plug this directly into this equation right over here. That will give us j omega epsilon times the E, which is what I just showed, times 0.1 sine of 10 pi x times e to negative j beta z. And this was also in the y hat direction, so let's not forget that. Is equal to this whole thing again. So y j pi over, move this up, omega mu sine of 10 pi x times 10 pi plus this whole thing again. 0.1j beta squared over omega mu sine 10 pi x e to negative j beta z. And it should, this thing turns out pretty nicely because these terms will just cancel out. This term. And plus these y hat components also cancel out. So all we're left with is just going to be j omega epsilon. This part doesn't cancel out. Just the sine part, I believe. Nope. This whole thing cancels out too. Sorry about that. E to negative j beta z. I forgot. The e to negative j beta z is also here, and it's also right here. So yes, sorry about the mistake. This part cancels out, this cancels out, and this cancels out. So the sine part and the e to negative j beta z also cancels out for each component. So this whole thing cancels out, these cancel out, and these cancel out. So all we are left with is times 2 j times j pi squared. So j pi times 10 pi is just going to be j times 10 times pi squared over omega mu plus 0.1 j beta squared over omega mu. So to simplify this, I'm just going to multiply omega mu on both sides to cancel out the denominators out. So we're just going to be mu on both sides times j omega epsilon times 0.1 is equal to j times 10 times pi squared over omega mu omega mu, and then multiply omega mu on both sides. That means these will cancel out, this will cancel out, this will cancel out, and on this side we'll be just left with, oh, actually we're able to cancel out the j's too. So the j's also cancel out. J's cancel out, j's cancel out, and just j cancels out, because we're able to just divide j on both sides and the j's will just cancel out. So we're just going to be left with omega naught, because it's omega here and omega here, times this mu term times epsilon times 0.1, and on this side we're just left with 10 times pi squared plus the 0.1 beta squared. And if we want to just make this simpler for ourselves, you guys remember that 1 over mu epsilon is actually equal to c. And if we wanted to find what mu epsilon actually was, if I square both sides, we'd be left with 1 over mu epsilon, which is actually equal to c squared. And then if I solve for mu epsilon would then just be equal to 1 over c squared. So if we can actually replace mu epsilon with this, and c means speed of light. So if I replace this, it would just be left with 0.1 omega squared over c squared equal to 10 pi squared plus 0.1 beta squared. Then I can factor out 0.1. So 0.1 times omega squared over c squared is this equal. So it's equal to 0.1 times 100 pi squared plus beta squared. I just factored out 0.1 out of this equation. Then that just means that 0.1s can get cancelled out. So 0.1 cancels out and 0.1 cancels out. And we're just left with omega squared over c squared is equal to 100 pi squared plus beta squared. Now, our main goal was actually to find beta. So to find beta is just simple algebra. So I can just move everything to the other side. So I'll be left with, so this equation will be as followed. Minus this, so minus 100 pi squared is then equal to beta squared. So plugging in, so now we just have to plug in omega and c. And omega can just be found by looking at the original E field equation, which was just right here. 6 pi times 10 to the 9th is going to be our omega. So 6 pi times 10 to the 9th squared over the speed of light, which, if you don't remember, is 3 times 10 to the 8th squared, minus 100 pi squared is equal to beta squared. And this would just be equal to 2 pi times 10 squared minus 100 pi squared, which will just be equal to 20 pi squared minus 10 pi squared. And this is just still equal to beta squared. That means once you solve for this, you realize that beta is equal to 54.41. Radians. So now all we simply have to do is plug this beta into our H field equation to finish the problem. And this is what we solved earlier. So if I remember, let me write this down on this piece of paper. Beta is equal to 54.41 rad. So now simply have to plug in everything. Omega will still be the same, which is a 6 pi times 10 to the 9. And mu is just a magnetic constant, which is just going to be 4 pi times 10 to the negative 7. So if I plug in everything, we would get something that looks like this. So H field is then is equal to x hat times 0.1 times a beta, which is 54.40.4 over 6 pi times 10 to the 9, 4 pi times 10 to the negative 7, and sine 10 pi x e to negative j beta z. I just plugged in beta, omega, and mu. Now I'm going to plug in the same thing for the z component right here, and we'll be left with plus z hat times j pi over, plugging in omega and mu, is 6 pi times 10 to the 9 times 4 pi times 10 to the negative 7 cos 10 pi x e to negative j beta z. So now we can just convert this equation back from Phasor, and if we write that, we will get h hat is then equal to this whole mess right here, and if you were to calculate it, you would get 2.3 times 10 to the negative 4. So x is equal to 2.3 times 10 to the negative 4 times sine of 10 pi x. And you should remember this e just means it's going to be cosine omega t minus bc. Just don't forget this omega t term when you're writing it back. Now transforming the z component, it will just be this z component is a little bit, it won't, so one thing you should realize that we still have a j term right here times this e term won't just give us cosine. If you guys remember this, you know that if we're on the real imaginary, and this is going to just be 1, and this is positive j, that means that this is 9 degrees. That means that this j is causing a 90 degrees phase shift. So essentially, for this term right here, this j and this times e to negative j beta z, we have something along the lines of I'll write this just to make things simpler. E times e to negative j beta z. This is essentially just equal to a to the j omega t minus bz plus pi over 2. So this just means that it's cosine x plus pi over 2, and this is basically just going to be negative sine, because sine is just cosine but with a 90 degree phase shift, right? So we'll just get, this is just equal to negative sine times x. So this will turn back into sine. So we're writing this z term, remembering that it's negative, so that means this z term will turn negative also, minus z hat times, if you were to simplify this, you will get 1.3 times 10 to negative 4 times cosine 10 pi x times sine omega t minus bz. So just make sure you understand that this j causes a 90 degree phase shift. I mean, when you multiply with this term, it will cause it to be sine, and it won't just be cosine anymore. And this is our answer.